Hi everyone, this video is for section 6-3, multiplication and division of decimals. So again, your textbook goes through some visual ones that I'm not able to really reproduce in this format. So again, what I would encourage you to do is please consult your textbook, make sure you are reading it, because some of your homework problems pertain to actually displaying how to solve multiplication and division problems if you are trying to do this from a visual or graphical perspective. So to begin, let's go ahead and multiply some decimals, shall we? So what I want you to note here is that before, when you were doing addition and subtraction, you had to line up that decimal point. And now that you are multiplying and dividing, you do not need to do that, okay? So it's kind of similar to the idea of fractions, where whenever you added and subtracted, you have that rule of finding a common denominator, but when it comes to multiplying and dividing, you don't. So in this case, what I would encourage you to do is maybe stack your numbers. So I'm going to take my 23 and 7/10, and I'm going to multiply that with my 14/100. So at this point, when you do the multiplication, and this is not a joke, I'm telling you, I don't care about the decimals at this point. Ignore them. They're just right now stray marks on your paper. So at this point, look at this as if it's 237 times 14. Okay? So that's how we're going to start applying this problem. So I'm going to do 7 times 4, which is going to give me 28. And again, I can carry that 2 over, unless you're doing your partial approach. That's fine as well, your partial product approach. So again, I will do 4 times 3. It's going to give me 12 plus that 2, so that's 14. Carry my 1 over to my next place value. And then 4 times 2 is 8, plus the 1 is going to give me 9. So now, essentially, again, because I want you to pretend that those decimals aren't there, I'm just moving over to that next value. So that means I have to put a 0 here, and actually, let's do a different color. I'm going to put a 0 here so that I don't accidentally let my number slip into that position. So now I'm going to do 1 times 7, 1 times 3, and then 1 times 2. I could technically work with the 0, but I'm really just going to have another line of zeros, so it's kind of wasted time, energy, all that stuff. If you have a 0 there, you can just let it go. So now I'm going to take these values and add them up, and that is going to give me 8, 11, carry my 1, 13, carry my 1, and 3. Now I can care about my decimals. Here's what you're going to do. You're going to count up the number of digits after both decimal points. So I want a grand total. So I have 1, I have 2, and I have 3. Here's how you're going to locate the decimal now. You ready? Are you on the edge of your seat? You excited? If you want more suspense, I would recommend pausing the video. If not, then just keep on listening, and hopefully you're taking notes as well. You are taking notes, right? And reading the textbook? I know you are. I know you are. Okay, so my decimal point technically is here if I'm treating this as a whole number. But I know from my initial problem that I have 3 digits after my decimal points. So I'm going to take my decimal and kick it 1, 2, 3. My decimal point needs to land in between my 3's here. So my final answer is going to be 3 and 318 thousandths. Okay? Let's move on to a division problem. Oop. Don't want to give away too much too soon. Okay. So our next problem, we have 4,032 ten thousandths divided by 56 thousandths. So here's what we're going to do. First off, let's remember our terminology. This is our divisor. Or no, sorry, I lied. This is our dividend. Followed by our divisor. I can kind of prove that or rewrite that to kind of bring back maybe a sense of calm or a sense of familiarity. So remember, we would be reading this as 4,032 10,000ths divided by our 56 thousandths. So again, remember that our dividend, here's our 4,032 10,000ths divided by our 56 thousandths. And again, we could write this in our long division notation. In fact, that's what I want us to go for. So again, our divisor is on the outside. Let's use our long division notation. And let's put our dividend on the inside. Okay, we're going to rewrite this problem a little bit more. I don't like all these decimals. It makes it harder for me to kind of work with. It's a little bit more cumbersome. I'm just not as familiar. I really wish that I could change this into whole numbers. Well, good news, everyone. We can. So, yay! Again, that's probably the most emphatic that I'm going to be, so now you have that on recording. So what we want to note here is I want to change my divisor so that it's a whole number. Well, how many times am I going to have to move my decimal to make that happen? 1, 2, 3. I'm going to have to move my decimal 3 times. Well, I have to do the same then. So what I do to my divisor, I have to do to my dividend. Okay? So 1, 2, 3. I mean, if you think about it, it's very similar to like when we are trying to adjust our fractions when we're doing addition or subtraction. If I multiply the bottom by 2, I have to multiply the top by 2. Well, let's go back up above. If I'm going to move this by 3, I have to move this by 3. So the way that my problem is going to look now when I rewrite it is going to be as follows. I'm going to have a divisor of 56, my long division symbol, and then a dividend of 403 and 2/10. I already know where my decimal point is going to go. Okay, so again, when you're working, just have your decimal float above, directly above it. Keep it in line. Okay, so here we go. I need to figure out how to divide 403 and 2/10 by 56. So let's spend some time here. Do not jump to a calculator right away. You are smarter and better than that. So I'm going to kind of go a little bit slow. Bear with me. Hopefully this is a good thing. You know, think of it like your notes. I'm going to overcrowd with detail, and then you can kind of strip away and find out what works best for you. So can 56 go evenly into 4? Hopefully you're shaking your head no. So we need to push out a little further. Can 56 go into 40? No, that's not going to work either. So I must have to check to see if 56 can go into 403. So here's where I might have to kind of play around and be like, well, maybe it goes in 6 times. And there's no shame in doing some multiplication on the side. So 6 times 6 is 36, carry my 3. So 6 times 5 is 30 plus the 3, that's 336. It's pretty close, so, but I always like to be sure, so let's do 56 times 7. 6 times 7 is 42, carry my 4. 7 times 5 is 35, plus the 4 is 39. That's pretty close. If I tried to add another 56, essentially, because remember that multiplication is a shorthand for adding the same value over and over, I'd go over 403. So it looks like 7 is the best fit. I'm going to do 392 below. And notice that I put the 7 above the 3 here. Because again, 5 went into 4 0 times, or sorry, 56 went into 4 0 times, and 56 also went into 40 0 times. Oh look, 007. So that's why I have the 7 over the 3 at this point. So when I do the subtraction, I'm going to, again, have to borrow or regroup, and now I have an 11. I'm going to drop my 2 down, and now I have to do this again. So let's think about, like, how close can I get? So let's just try 56 times 2. Oh, wow, perfect. So we have it. So I'm going to put a 2 here. We'll do that. And we have no remainder. So my answer is actually going to end up being 7.2. And remember that we call an answer from a division problem a quotient. All right, last one, everyone. So let's keep going up. Oop. Let me get rid of those lines lines first. Work with me here. All right. So we finally have 482 and 91 10,000ths times 1 million. And if you need to, always feel free to add those commas in. It might make it easier to read longer strung numbers. Whenever you are multiplying something by a multiple of 10, so in this case 1 million is a multiple of 10, it makes it super easy. How many zeros do you see in this problem? I'm counting 6 of them. So what I'm going to do is I'm going to take my original, my first factor that's been provided to me, and I'm just going to kick it back 6 times. Because that is essentially what we are doing when we are multiplying by a multiple of 10. Essentially, if you think about it, for every 10, we are moving our decimal place. So a 10 times 10 gives you a 100. 10 times 10 times 10 gives you 1,000. We've covered this idea before. Now we're just doing it with decimals. So I'm going to fill in those empty spots with zeros. So now my answer, I'm just rewriting it, and I'm going to put in some of those commas to break it up and maybe make it easier for me to read. My final answer is 482,009,100. I hope this video was helpful. If you have questions, let me know.